Good day, everyone. I'd like to start by introducing myself. My name's Calvin Carl M. Villanueva. Together with my thesis partner, Zyrene Del Rosario, and on behalf of our thesis advisor, Engineer Brian Benaventura, we intend to discuss our thesis topic, which is upgrading the Mount Cadig nickel laterites by beneficiation techniques. So first, our general objective is to determine the upgrading response to physical beneficiation techniques for nickel saprolite and involves crushing, grinding, and screening. So basically, what is beneficiation techniques? Beneficiation is the process of ore dressing wherein the samples are reduced in size and gangs separated from the ore. While nickel saprolite is a type of nickel laterite which is formed beneath the limonite zone, and it contains generally 1.5 to 2.5 nickel and consists largely of magnesium depleted serpentine in which nickel is incorporated. So for our specific objectives, to provide an evaluation that will demonstrate the possibility of increasing nickel grade from saprolite ore obtained by the VIL Mines Incorporated. Second, to apply the ore beneficiation techniques to achieve liberation of valuable mineral by size reduction and separates gangue minerals from ore. And for the last one, to at least separate silica from nickel-bearing garnierite by physical beneficiation techniques. So, garnierite in the packets of features of the serpentinite rock, green garnierites can be present in minor quantities, but with a high nickel content, mostly 20 to 40%. So, for the scope and limitation, this is physical separation techniques will only involve crushing, grinding, and screening. Limitation: this study is restrained to the provision of proof of concept in increasing the nickel grade from the saprolite ore obtained by VIL Mines Incorporated in Mount Cadig, Tagkawayan, Quezon, Camarines Norte. So for our methodology, initially bulk sample will go through sampling, which includes splitting, and methods of quartering and coning. This method focuses on the operation of removing a part convenient in size for testing from the whole, which is a much greater bulk, in such a way that the proportion and distribution of quality to be tested are the same in both the whole and the part removed. The first kilogram sample, which is the raw sample, will undergo sieve shaker for 25 minutes to expose the particles in a sample to all openings in each sieve stack. Then, the particles retained from each sieve are weighed. The mesh size that will be used throughout the experiment are 100, 150, 170, 200, 230, 325, and 400. The second sample will undergo ball mill for 70 revolutions before being put to the sieve shaker for 25 minutes. It is weighed per sieve stack and send it for chemical analysis. The third sample will undergo ball mill for 140 revolutions before being put to the sieve shaker for 25 minutes. It is weighed per sieve stack and sent for chemical analysis. The fourth sample will undergo ball mill for 210 revolutions before undergoing the sieve shaker for 25 minutes, weighed for sieve stack and sent for chemical analysis.
Good afternoon. I am Saidin Del Rosario and I will discuss the result of our experiment. So first, we have petrographic analysis of the sample that shows the presence of goethite, magnetite, and chromite. Presence of goethite indicates that the sample is a nickel-bearing mineral. Second is the XRD result. The peak intensity represents the atomic composition in the crystal structure. As you can see on the graph, it indicates the presence of goethite, chromite, magnetite, and lizardite, meaning goethite is a predominant mineral within the saprolite ore. Also, presence of lizardite shows that the sample is a siliceous type. For the acid result, it will show the potential value of a mineral. As you can see on the table, presence of nickel and other elements are present on all samples. but the percent recovery drop per sample since the particle size is too small that it tends to be a production loss during processing. Particle size analysis aims to divide the particulate material into size fraction. This process is used to classify mineral sample by obtaining grain size distribution curves to determine the mesh size of the required passing rate. So far, for the graph, it indicates that when we increase the grinding time, smaller particle size is recovered. While the second graph shows the points of the percentage passing for each sieve size. As you can see, Cadig 1 sample has the highest recovery rate among the tests conducted. Based on the data gathered, it was concluded that there are no significant upgrade among the four conditions. Disregarding the retained weight of the sample from 100 mesh to 170 mesh, a percent upgrade difference of only 0.01% in general were recorded. There are several factors to consider proving that the theory is reliable feed grade, mass yield, and efficient in metal recovery. Load-bearing nickel can be profitably mined provided that the ore is amenable to beneficiation. Considering that the data obtained as a basis, it was proven that physical beneficiation alone was not be able to increase the grade of the nickel laterite from one Cadig. For the recommendation to further improve the nickel grade, it is suggested to incorporate reverse flotation in which nickel particles are depressed and gangue particles floated. So that's all. Thank you.